going to talk today, this talk is going to be is requirements are going to be changing all the time. And how can we keep up with those requirement changes, and how can we model our systems better to keep up with that change? So I'm going to be making some assumptions in my talk today that all of you are using some form of context, or at least striving to get to a bounded context. And I'm going to be writing some code. Hopefully, if I'd said my prayers to the demo gods, my live code would go well. And I will be coding in .NET. How many of you are using .NET C#? Oh, good. Okay. Okay. So you'll be able to follow along. And I also kind of assume that you understand messaging, and or at least understand that in order to do DDD better, you need to have some sort of messaging. So something about me, yes, I love to rock climb, but besides that, I started getting into event-driven architecture and messaging architectures about 7 years ago. And up until then, I used to code everything in WCF, and I thought I was the coolest programmer ever. If I could get into the pipeline and look at the inspectors and do some really cool stuff, so that was my thing until I learned about temporal coupling, and then it all went downhill. So the temporal coupling sort of like came to me when I was in Starbucks, and when I looked at Starbucks and how Starbucks really serves their customers, starting from the cashier and how they serve their drinks, you can understand all about messaging and asynchrony and event-driven architecture, because it reduces all that coupling. You don't, the cashier doesn't wait for the barista to, get the drink ready before they come and charge you. So real world operates in a very asynchronous manner. And if we can model our software after the real world, where everything is based on events, then that's a good thing. So the whole thing is about change, and we want to model our requirements. We want to model our software after the changing requirements. And we're here because we love good design. And the whole purpose of good design is so we can keep up with the business changes. So if the software that we write can't really keep up with the business changes, then we're kind of failing ourselves and our businesses. And the big thing about DDD is it helps us focus more towards the business activities and processes, more so than us trying to model the actual data, and more like getting away from this entity-driven architecture, more towards like activities-based architecture, where you're focused more on what is bringing the business the money, where are the bottlenecks, where are the trouble points in these business processes, and how we can improve them. So if we start to think along those lines, then our software looks and starts to look better already. So let's talk about business processes. If you're wondering what this is a picture of Messine. I was there this is Greece, and I was there with my kids for vacation. And if you look at this picture, you can see that there is some kind of order or sequence. You can see that some concentric circles. This is actually a picture of the grave circle in the palace of Agamemnon. So you can see that there is a specific, layout, and there's a sequence, there's concentric circles, and the architects of those thousands of years ago, they designed it to be this way. And it's kind of like, as soon as you see this picture, everything looks very clear. But then if you try to take it to the business process, it's kind of like hard. Where do you start with all these complex rules? And one way to look at and model business processes is to use event storming technique. I learned this technique at Matthias's workshop at this DDD conference on DDD and message-driven architectures. And so with event storming, you start with the most critical event for that business process, and then you start looking at what drives that, or how you could arrive at that event. And then you start to look backwards. Once you receive this event, what are the other possible outcomes and other events that can get triggered as a result of this. So you kind of start to get a big picture of your business process. And of course, this is something that you should do with the domain expert in the room with you, so you get a better idea. And the whole concept here is you're talking about this, so you want to kind of learn about the nuances, and you ask them, you start the questions with, what is the most troubling point? Like, what is the problem here, or what are we trying to solve? So then it starts to, you understand the events, and you can understand the constraints better. So as an example of a changing requirement, I want to talk about the American Air Advantage. I am still a proud member of the American Air Advantage Frequent Flyer Miles program. So the way it works is, before 2017, the way it used to work is there were 3 levels of frequent flyer programs, like gold, platinum, and executive platinum. So all you needed to do was get either 25,000 miles or like fly how many ever segments. So if you went from San Diego to Denver, 30 times, you're good, you get gold. Or if you went to London or Europe a few times, you accumulated those miles, you're good. So in this model, if you were to assume that the loyalty program or the loyalty context had all this data, then it's pretty straightforward. As the flight segments, as the customer keeps flying these segments, this context has enough data to compute, has this customer flown enough segments or enough miles, and you can come to a conclusion, and everything is good, and you can publish an event saying, like, yep, let's promote this customer to gold. But then in 2017, American Airlines changed their policy. Now, it's no longer necessary for you to just fly 25,000 miles. You also need to give them $3,000. And that's how I am no longer a gold customer. And I flew United on the way to Denver. So there you go. So now, how does this affect our complexity? So the problem now is that price or that amount that was paid by the customer is not in the loyalty context. It is in a different bounded context. It is in the payments bounded context. So if we are following DDD or good design principles, we know not to share important data, or we don't ask bounded context information like, hey, how can I get this? So you don't do that. So now all of a sudden, you're using DDD because you want to do good design practices, but now your data is in 2 different places, and how do you do this? So this is where messaging comes in and helps DDD. So in order to communicate between different bounded contexts, you use messages. But there are 2 types of messages. You have commands and you have events. So to try to understand commands and events, let's take Greece and Spartans, for example. So you have the Spartans on one hand, and then you had the Persians on one hand. So if you consider them as 2 different bounded contexts, with completely different rules and stuff, how do they communicate? Well, Persians sent a messenger to Spartans. And what did they do? They sent a command. They said, surrender. And what happened to the messenger? The messenger got killed. That's right. So you don't send commands between bounded contexts. What you want to do is, as the Spartans taught us, don't use commands to communicate between bounded contexts. You want to use events. So if you look at commands, the important thing about commands, it's you can use commands within a bounded context because you own the data, and you have to understand that commands can fail. So it is also a message. It can fail. So you need to design, what are the compensating actions I need to have if in case I'm sending this command, if this command fails, what do I need to do? So you need to think about that. But when you're trying to name, and on the other hand, events are something, it's like a statement of truth. you only say that when something has already happened. So it's in the past already. So you can't, yeah, so it's like a statement of truth. So how do you go about naming these commands and events? So when you want to model these messages, these are messages, when you want to model these messages, you want to use, of course, a language that is understood by the domain experts and language that implies that context. So for commands, you use action verb, like imperative, like what needs to happen, like the Persian said surrender. So for events, you want to name them in the past tense, as like flight segment was added or reservation was booked or something in the past tense. You don't need to add tag command at the end or event at the end because you don't need to. Then that's our programmer and us trying to like introduce like technology. Like you don't business doesn't need to know whether it's a command or an event. It's a thing. So now you have these three bounded contexts, and in order a business process will need a business process for a certain thing to happen, it needs to there's a certain sequence of steps. First, customer needed to have paid this much money, and then they also needed to have flown a certain amount of miles. So it can cross across different bounded contexts. So this is where, in order to model this, a Saga pattern can come in handy. There are different, in the internet, there's probably a lot of contention around the naming of the pattern. Some purists might argue that cannot be called a Saga, but we will leave that out of this discussion. And so basically, the Saga pattern is where you have this thing, and different messages come in, and there is state involved, because as these different messages come in, the second step of the process needs to know a certain state. So you have to share this state, and that's where the Saga pattern is handy, because each message it happens, like the action of what needs to happen in the message handler, it's atomic, it has its own transaction guarantees, but that state can be stored, and that state, you can restore that or rehydrate that state when the next message comes in to make some decisions on what you need to do. And as a result, you can send more messages out or whatever. So this is kind of, in general, like how the Saga pattern works. So if I were to like show this of an implementation of this pattern, so a message comes in, and you create this Saga instance, and the Saga instance operates on a state data, so there is some state data involved. So when the message comes in, you call the right message handler for it. If it's the customer has paid, then you go and invoke the handler for that message customer has paid. So you dispatch the message, invoke the handler, and then if that handler, as part of handling that message, needed to send out more messages, then you do that. And you persist that information along with the state in some persistent storage. So now, let's say another message comes in that belongs to the same Saga instance. So basically, like this customer ID 123, like the customer ID has purchased, and customer ID, that same customer has flown certain miles. So the event that says like, hey, I've flown certain amount of miles, when that message comes in, we need to rehydrate the appropriate Saga information back from the database. So when that message comes in, what we do is we pull, based on the ID and the customer ID, the correlation information, we pull the correct Saga instance. We rehydrate that along with the state. And then we dispatch the message to the handler. And if at that stage, based on our state data, if we can make that assumption that everything is OK, then we can complete that business process. So how do we actually do this? And this is where I'm going to kind of show you a little demo. So I coded up this Saga last night. So here's the preferred customer's gold policy. Basically, as you can see, there are two messages involved. One is segment was flown, which gets triggered whenever a customer has flown a certain segment. And then the other message is that the customer has paid. So the message handlers are very simple. So when this Saga gets this segment was flown, it invokes this handle method for the segment was flown. So all we're doing here is we're remembering the state, we're storing the customer ID, and we're incrementing the miles. So the state data is actually very simple. It's just a class where we keep whatever information that we want to remember about that process across these messages. So message handlers are like don't have state by itself. So this is when you want to share the state across multiple message handlers, this is useful. So whatever information you want to share across these different message handlers, you just put it in your state object. So now you ask yourself, hey, can this customer be promoted to gold? And if that's the case, we can publish an event saying new customer was promoted. Customer was promoted to gold. And then it's done. And again, keep in mind that the customer can also be made gold based on the payment. So you need to also check. So if the condition for being promoted to gold is pretty simple, if the miles is greater than 25,000 and the customer has paid X amount of money, then that condition is satisfied. So both these message handlers check for that condition. So if that goes okay, then then the Saga is complete. So let me run this. I hope you can see. OK. So this is the policy code that's going to determine whether or not the customer can be made gold. And then I have this little XC here that's going to listen to when the customer is made gold, what needs to happen. So, oops. So what I'm going to do now is I have this, since this is a test application, I'm just going to assume that those messages happen, and I'm going to press some buttons. So I'm pressing F. So I'm publishing that a segment, customer has flown a certain amount of miles. Let's see, they've flown 10,000 miles. So I have this little tool that lets me see what's the view. Oops. Sorry, this is all so small. There you go. So if we zoom in, can we? There we go. So the segment was flown, messages come in, and it's updated the state as 10,000 miles. So let me exit this. So now let me go in and publish a few more. So now the customer has flown at least 10,000 miles, 30,000 miles. So if we refresh, there is an auto refresh, but it's just not fast enough for me. Oops. I sorted it differently. Let me just refresh. Great. So let me just go ahead and just trigger a payment event. Yeah, sort by date. Let me sort by date. There we go. Thank you. So now we can see the different messages that participate in this business policy. And as you can kind of see, that the properties are being updated, and the miles have been updated, and the payment is updated. But still, you can't really make them preferred yet because the customer hasn't paid the entire amount of money. They've just paid 2,500. So now, if we go and refresh one last time, And if I don't click the sort button, so you can see that the customer has paid, and the amount has been updated to 5,000 now. And that was enough for us to figure out that this condition is satisfied. And we published an event saying customer was promoted to gold. And this other process that was listening to that event has also been notified. So let's say that now American Airlines can say, woohoo, you've attained your gold status, and things like that. So you could add subscribers to do this. So OK, let me stop debugging. And switch over. So this was great, but sometimes we need to model time. Time is a very, very crucial element of business processes. So time can be modeled like using timers, but timers are not durable. If you restart your process, then that customer is never going to be made preferred because you've lost all that information. So how can we model time as a durable thing? We can also use messages to model time. So that's one good way. So let's say the requirement is changed to the point where they're saying, yeah, you have attained the gold status, but it only takes effect in the next calendar year. So it's great that you've got all this, but your gold status is going to start to kick in like in the calendar year. So now you need to model this sort of time. So let's see how we can do this, and this is where I'm going to do some coding. That's it. OK, so the first thing we need to do is we need to remember that we need to help ourselves. We need to have this wake-up call. Like so the wake-up call in this case is that a calendar year has occurred, or a calendar year has started. So let's just create a class. Can everyone see the code? OK, back, great. So let's create a class. This is just to explicitly model this wake-up call. So I'm just going to call this calendar year has started. So it's just an empty class. The purpose of this is just to model the fact. And so the next step is we can't publish the event. We can't call this business process complete as soon as the customer has attained gold. We have to wait until the calendar year is started. So we need to take out the part where we mark the business process complete. OK, so that's done. The event there that says customer was promoted to gold is still useful, because that's the point in time where the customer attained that status. So that is good to have, and that is still good to publish to the outside world. So we can keep that. So now what we want to do is we want to we want to be able to start this time thing. So what we're going to do is we're going to request a timeout. And in this timeout, we're going to say, is it time span? No. Time span. I'm just going to use like 15 seconds. I don't want to wait for a calendar year. And then I'm going to just pass in the state object. Calendar year has started. So, this is an async method, so we want to await this. And because you use async, you got to configure await of false. I wish this was the default. You didn't have to write configure await false for every time you await. But OK, so we've done that. We got to do the same thing for the other the other message that comes in. Of course, you can make this code pretty and not repeat yourself and stuff like that. I just am doing this just to keep it simple. So you see that there are two messages and just to make it simple. So this Saga has this configure how to find Saga. That's just a infrastructure magic that nService bus uses to tie the Saga instances together. Sorry, I am using nService bus to implement this Saga pattern. And disclaimer, I work for nService bus. So you can use mass transit if you're in the .NET world and if you're trying to explore like other event buses. So we requested timeout. And now, OK, so we said that I need to be able to, so wake me up, remind me. But that reminder needs to come back to you. So you need to go in and say, I handle timeouts. And what did we call it? Calendar year has started. And now you need to implement this method. There we go. So this is the method that's going to get invoked when that time has elapsed. So here we can say, OK, we can publish context.publish. So there's an event custom activated to gold. Gold status activated. So customer ID equals our state has the customer ID, so we can pass that in. And because this method is async, we need to await this and add the configure await stuff. And because we're awaiting, we need to make this method async. And let's just go and write something. I don't know, something. Customer status gold has been activated. How about that? So far, so good? Cool. So now let's just run it and see what happens. Let's build this. Hey, no compiler errors. That's a good start. OK, so same policy. And then I will just bring up this subscriber as well that's listening. OK, so let me get rid of that. So I'll just publish a few messages for the flight. And let's see. Let me go here, refresh. Note to self, don't click the sort button. OK, so as you can see, the 3 messages for the segment was flown has been incorporated. Let's go in and add the new 2 payments. So this should now have promoted the customer. But now if you see that once we've published that event, customer was promoted to gold, we have also requested this timeout. So here in this case, the timeout is 15 seconds. And so this calendar year has started. That is just a message that has been dispatched. So that's just to indicate that, hey, wake me up after this duration has passed to go and do my operation. And I hope I've talked enough for longer than 15 seconds. So let me refresh. And there you go. So once the 15 seconds have elapsed, the framework in this case has sent that message that was stored back to you. So this is like your wake-up call. And in this case, now the goal we now can publish the message saying gold status activated because it's a new calendar year. So if we look at the console, now you can see that the other application has also received the event gold whatever status is now active. Yeah, how about that? Cool. Thank you. So I guess I can leave this. So going back. So, but as you saw, in whatever, less than 30 minutes, we were able to make some changes and implement a business policy with time calculations and things like that. That wasn't hard. So what is hard about this is the fact that you need to understand the business constraints. You need to ask what are the rules that that is hard to tease out of these domain experts. What is not happening, but is important. For example, let's say the customer has, in this case me, I got so close. I got to I got 25,000 miles, but I got so close. I paid American Airlines $2,800, but I was short by $200. So what if the business wants to say, hey, we see that you were so close to getting the status. How about you pay us $500 and we will give you this gold status for free? Well, that's what they do. I got an email from American Airlines saying, hey, you can upgrade to gold status and you can just shell out $500. So again, that's a business rule. But you don't tend to see that rule right away because it's not visible or upfront, because this is not an event that's happening, but this is an event that you're kind of looking for. So these are sort of the complicated questions that you need to ask your domain experts in trying to tease out these nuances so you can build these into your business policy. So this is the hard part. And also things like, okay, in this context, the gold status was activated. What do we do about people that, when, let's say, when you moved from the old policy to the new policy, do you just ditch the current people who are already gold, who haven't spent that money? Or do you say, hey, let's just send them a notification to let them know that this policy is about to change? So as a programmer or a designer, we don't have the answers. The business has the answers. So these are some of the things that we need to get out of the domain experts, which is really hard to do. And because we've taught the domain experts like our language of how to speak, and they try to explain us in like user stories or like programming language. So it makes it even more harder to actually get to the business requirement. And again, if you ask yourself, if you ask your domain expert, what is like the trouble point? What are the trouble points that you currently have? Or if you start looking at the financial aspect of it, of how the business is trying to improve the financial model, how can this business policy affect money? Because ultimately, it's all about the money. Business is trying to make money, and they have to change in order to be the coolest business, so they can get more money. And so in order to do that, they have to change. And if they change, then the software that we write has to change. But if we write software that stays good for 3 years, and after that, it can't keep up with the change, and I'm sure how many of you have at some point thought to yourself, we need to rewrite this all over again? Yeah, exactly. So that's not our goal. Even though it might be hard in the beginning, we want to make sure we think about these cases so when that change arrives, we can extend our software. So this is kind of where messaging for me was like a eye-opener, because when you start modeling things around events, so business usually says, when customer became preferred, we want to do something. Now that is an indication of like customer became preferred as an event. So when they say, when this happens, go do something, then you can simply just add a subscriber to that event and capture all that logic of what you need to do in that one module. So now you can, it's easy to change that code. You don't have to touch anything else. Now this gold policy, you can create one for your platinum, whatever, platinum or executive platinum. And let's say they change the platinum policy, you don't have to go and change the gold policy. Everything is separate. So it gives you, by modeling your stuff after events and using event-driven architecture along with DDD, it really helps you out. So I wanted to give you a link here. This link will take you to Udi's advanced design course where he talks about long-running processes. And so there's access to 2 videos, and you can download them. And I will make my code available on GitHub. It is not there yet because this was written like last night around like 11:30. So I will make it available sometime today or tomorrow. Thank you very much. And questions? Yes.
So it's interesting that you brought up the idea of a saga pattern, because we use a similar concept called a process. And rather than rely on a timer or a time span to delay certain events from being published, we rely on a timestamp, and we rely on another supervisor service that will track for that timestamp to take place. And so, well, it has its own pros and cons.
Right. So, yeah, you're right. The process manager is a very similar pattern, but I think where it differs from the Saga is like the Saga treats everything as a new instance. So every customer has its own instance. So it gets a new. So every customer has this life cycle of things that are being kept track of, and I think the event processor has just a single life. I mean, it's just the one thing. It looks at collectively everything, so that's the difference. I'm not exactly sure how you would do time in that model.
We rely on the
timestamps. Okay, okay. So if you need something where I'm trying to think. So if in case you need to take actions based on like per customer level, then this might make more sense to you, because the lifespan of this is per customer. So if you have 100 customers, you have like 100 instances, one per. So I think that's where it might come handy. Yeah.
It's useful in a situational sense. So
Right.
it's really,
Cool. Thanks.
Okay.
Oh, and sorry, one more thing I forgot to mention was this is a trouble that I had like last night. Was like, okay, who owns this business process thing that we've written, and does the the payments context own it, the loyalty own it? So before I called it loyalty, I'd called it like flight segments or something. So I had this trouble of like, I have this business policy, but it doesn't make sense for flight segment planning thing to own it, and it doesn't make sense for customer payments context to own it. So I had this trouble, and so when we changed that to loyalty, kind of started to make sense that, yeah, duh, like this business process is talking about keeping track of gold versus platinum. It naturally fits in this context. But sometimes you can have like a business process that spans across different contexts. That could be something like business intelligence. and where you're making decisions based on a lot of events from a lot of the context, and then business is trying to figure out like why certain thing has happened, or how can I make more money out of this policy, or what changes do I need to do to this preferred program in order to get more out of this. So they probably did that, and that's how they probably added the $3,000 more. So so that's one thing I wanted to mention. Sorry.
That was your question.
Oh, great. I read your mind. Yes.
So, since you request timeouts for sagas when you delay a publish of the event, in the event of an outage, how can a saga keep track of how much time has elapsed?
So the timeout is a message, and as part of the saga, it gets persisted. And if for any reason, like that, like let's say, right when you were trying to save that message into the persistence, it blew up, then that particular transaction, it is a transaction that will roll back, and that message that the fact that that message would be in the queue. So you won't lose the fact that that you requested a timeout. And if things fail, like let's say after, where you've already you persisted the message in the persistence, so now when the process comes back, like in this case, N-Service bus infrastructure, the implementation of Saga will keep track of that, and we'll scan like the persistence and find out like what oh, these messages have elapsed. We need to send it back to the process.
That's good.
Cool. Thanks. Any other questions? Well, thank you very much.
Thanks, Indu.